Hello, welcome. Good morning, good afternoon, good evening, wherever you are in the world. Thank you for taking time to attend. On behalf of All India Orchestras Group, a very warm welcome to AIOG Weekly Webinar Series. Before I introduce today's speaker, most of you know about All India Orchestras Group. AIOG is a community of Oracle experts who are willing to share their knowledge and expertise with the peers in the industry, community, and Oracle. This is your opportunity to share your feedback, insights, and experience about Oracle products while networking with like-minded peers. So we are bringing best out of Oracle technology to you. It is your responsibility to share with your others, especially with your connections. And this series is very unique webinar series. As you can see, the entire month we are bringing the experts from Oracle East program, and some of them, if you're first time attending, if you're first time hearing about Oracle East program, Oracle East program is it's basically recognizes, rewards individuals for contributing to Oracle community. It is a something like a very premier program, showcasing your expertise, understanding of technical abilities with Oracle product, and the community typically do a lot of contributions, like for example, speaking at conferences, writing blogs, technical articles, contributing to users group, and many things, right? So there are a lot of benefits. I request you to please go to the website ace.oracle.com, and if you are interested, please reach out to me, or you can reach out to anyone in the program. We will definitely help you. So with that, let's go to the next slide. So some of the housekeeping tasks, please look at the Q&A bottom of your screen. Please ask your questions for speaker at any point of time by typing in Q&A only, and speaker will answer appropriately. Please prepare your questions properly before asking. Sometimes you need to provide the context, otherwise no single line, single messages doesn't work, right? If you need any support during the event, please use the chat feature. Our team will monitoring, and we will assist you with any queries. And also, we need to really thank speakers. They're coming in the early morning and they're preparing, content for you. You need to really thank them. You can connect them in the social media and thank them. And also, we'll upload the recordings and presentation material to the website. And here are the different channels. You can scan the QR code, and you can join and get the latest and greatest updates from AIOG. So with that, we have very special speaker, first time coming to AIOG community, and I've been reaching out to Pete for a long time to come to India. I'm not sure when this is going to happen, but at least we are bringing him virtually. Pete is, I'm not sure how many of you actually followed him and connected in the LinkedIn, but it's a very, you can see always a very happy face, number one. And also, he's a database consultant and DBA. He has been with IT since 1987 and specialized in Oracle, Postgres, and all the database related technologies since from 1994. So he comes with a lot of experiences. Please ask your questions. Um, and I think you'll hear very unique session, microservices and databases, how to combine. So with that, very warm welcome, Pete. This is a very warm welcome from India, and hopefully you'll enjoy the questions from us. And also one day we want to see you in India. Okay. So with that, I'll hand over to you, and you can start sharing your screen.
Okay, thank you. That was a very gleaming intro. Putting my screen, that would be this button, and bear with me while I push the share button. There we go. Well, you've read the abstract, didn't you? All of you, most of you. Um, I'm going to talk about microservices and databases, how to do it smartly. There will be a bit of smart DB in there, of course. You told me that I should talk about the ACE program, but you've already done that. Thanks for that. I'm very happy to be part of the Oracle ACE program. I could go on about that forever, but nah, recommend it, guys. Microservices. A little bit about myself before I do that. I tend to go around on a motorcycle. I thank you again for inviting me to India, but it is a bit of a long ride. The closest I've ever been is like this. As I was standing on the border of Russia here. That's why I took the picture. Um, I'm also a bit of a dinosaur because I'm a really old DBA. That's why I took my picture in front of the Dino store. This is in Poland, by the way. This was my next motorcycle. Agendas are so last decade, but I'm going to tell you a little bit of history because you can't know where you're going if you don't know at least a little bit where you came from. Microservices and why they were invented, and they're fine. Stateless, most DBAs know about state and stateless applications. I'll just do a quick recap. I'll give you my ideas on how I think a database should fit in a microservice, or maybe just my ideas on how a database should fit in, period. I can never resist mentioning the competition, Postgres, Yugabyte, but we'll glance over that quickly. And just in case the Oracle people are listening, look, I know Oracle is the best database out there. That we don't need to discuss that, but we should look at the competition from time to time. I'm a dino. Sorry about that. Oh, if there is time at the end, I'd love to have a discussion. I'm not a particular fan of webinars because I can't see the audience. I can't see whether you are snoozing away, chattering amongst each other, or listening attentively. So, please give me some feedback from time to time. There we go on microservices. From the Corona time, I took the image of the Corona virus to represent a microservice. I thought it was kind of fitting. Microservices are everywhere. And if I'm critical in the rest of the presentation, keep in mind that I actually came across microservices years ago, and I'm a fan, and I think it's a good concept, and we should learn and apply where possible. But it's not always the best solution to your problem. Microservices are about two things. You want to decouple parts of software. You want to be able to build and maintain one part without affecting the other parts of your system. And in the 80s and 90s, we used to call that modular programming. There is an old abbreviation out there called SOLID. If you want to take anything from this presentation, take a screenshot now and Google SOLID after the presentation. There are interesting concepts in there, they still apply. The other thing about microservices, the sales point, they're supposed to be scalable. And what most microservices people mean by that is you can start one or two or three, become resilient, and then you can start 4, 5, 6, 7, 8, 9, 10, and scale to the universe. Beautiful. Yeah, there's a database in there. Okay. Microservices are about building a serverless system. This is what your this is what your architect wants to hear. Are you serverless? Yes, I'm serverless. Okay, good. Tick in the box. Are you agile? Do you do DevOps? Yes, we use microservices. Of course, we are agile and we do DevOps. Microservices run on a laptop, right? Can you use Kubernetes? Are you ready for Lambda deployment? Can you do on demand, pay as you go, all of that? Yes, microservices will help you do that to a point. So, yeah, you're hip and trendy. Welcome. And microservices need data. When you save something, you save a state. And this is where some of the gurus came in. You always have that database in your system. And here's a Java guy, Vlad Michalcha. He's from Romania, which is closer to India than I am. You should Google Vlad. He does Java courses, Java instructions, Java blogs, Java everything. And we're good friends, by the way. I don't hate Java. But he then says this: a true by the book microservice requires a separate database per service. And then he goes on and says, yeah, we had coffee in Romania. I'm not sure if that's going to work, because in reality, more databases mean more of everything: monitoring, backup, security, replication, more DBAs. And then, he sits there across from me smiling, I don't want more DBAs, really. Um, and we are both a little bit fan of the other database. And here's the database you do need. We call this little guy DB, and it's the Oracle mascot. Some of you may have seen it. My name for him is DB. So the message on this one is, yes, microservices are great, but you need to connect most of your microservices to a database. And that's where some of the problems come into. That's why this presentation was built a year ago or so. So what is a microservice? Well, in most cases, a microservice is probably known as a URL. There is a connector somewhere, a URL, you call it, generally from a browser or an HTTPS call, and there you go. It's in a cloud, by the way. Oh yes, you're in a cloud. Yeah. A microservice tends to be a get, post, put, etc. It tends to be HTTP interface, if you like. So you have an application component, the code, and most of the time there is a database behind it, a data store, an RDBMS, or a doc store, or some storage mechanism. A lot of microservices just write stuff to disk, so you end up with a lot of blobs, objects. It could just be files, by the way. Microservice will do something like this sequence of activities. The user, the consumer application calls the URL, doing an HTTP over the network. That activates an application, and the application calls a database. The database does its thing, it picks up the data, it returns the data, it saves or commits the data, if you like, and returns a result. And hopefully, if you've done it right on both the call and the database, you avoid 400 and 500 errors. So everything's going well. This is the optimistic scenario. Your database does its thing inside your microservice somewhere. And yeah, your database tends to be the dinosaur. No. So state. What are we doing with state in a microservice? I think, and for the benefit of this presentation, you have three scenarios. You can have no state at all, no data. Data is null. I thought it was a nice quip. What you then have effectively is a standalone program. It doesn't need state. You have to wonder, do we really not need state? My program itself is data, but right? Examples are like something like formatting a string, converting Fahrenheit to Celsius to Kelvin, compressing a stream, that sort of thing. Those are easy use cases. They are simple, but how many of those do you have? How often do you deploy a program to convert Fahrenheit to Celsius? No. Most applications, most components, most microservices have some sort of state. And if you're lucky, it's just read only RO. So you're still more or less stateless. You only have one state. You don't really modify the state. You return the data, some data. The examples for this are you do a catalog lookup, a zip code lookup, web shops where the pictures are stored separately, list of values. A very typical one is the verification of a zip code. And you might need a database. You probably should have a database. But if you're lucky, you just have to read that. That is still a really good case for a microservice, by the way. The problem appears when you have a stateful service. You need to store something. Now you need ACID or base. Base, look it up. It's like a basic consistency eventual. I always forget. It's on the bottom. Availability, soft state, eventual consistency. That base means your data is not that important. ACID probably means your data is very important. You need a database. You need to store that data somewhere. Best examples are things like stock keeping and the classic bank account problems. You need updates. You need storing the updates safely, committed, Make sure it's atomic, consistent, isolated, and dependable. That's what ACID is for. The third case is the hard nut to crack, of course, because you need a database. And you could use any database, and we would prefer to use Oracle. Further down, I'll probably make the case that Oracle really is the best database for most use cases. So standalone system is fine. You can build that. Most of you probably did. Most of you did it in school. Hang on. What's happening? Oh, sorry. Sorry about that. My keyboard doing. Yeah. So your first case is a standalone microservice. You're not doing any data processing. Just convert something. Typical case, format a string, compress a file stream, something like that. You have no data needed, or no additional data needed for your application. You don't need any extra components. It'll be a small program, easy to containerize. You can use Kubernetes. Boss happy, architect happy, because we're containerized. You can deploy and scale out easily, because if you have one of them running, you clone it. You have 2, 3, 4, 5 running. They don't hurt each other. They don't need to touch each other. If you have enough hardware, you're fine. You can deploy to a cloud with no problem. And if this is your challenge, if this is your business case, your use case, lucky you. You have a microservice and you are buzzword compliant. Oracle likes to be buzzword compliant, whatever the new buzzword is. So there you go. But what you've built is, in my opinion, a calculator. And you can mass produce the calculator. That's fine, but it's only a simple calculator. Now, what happens if you need some read-only data, some data in your microservice? Examples of this is you need to do a zip code lookup, or you're displaying catalog, you're searching catalog data, typical web shop stuff. You might need images, which tend to be a big component of data, but luckily images are static. Your choices are two. You can either include the data in your microservice, or you can call the data for your microservice. If you choose to include the data in your microservice, you're building a little database inside your program, inside your service, inside your image, if you like, inside your container. And by doing that, the moment you create the service, you fix your data. So the timeliness of your data is fixed, and you won't get updates because the service will get deployed out in the cloud world somewhere, and it'll contain the data from the data that was there at the moment of creation. So the question is, can you afford to deploy the old data? And funny enough, well, lucky enough, in most cases, you can. Not all data is time critical. The other thing is, if your catalog is gigabytes in size, you create a rather fat microservice. And a fat microservice, a big file effectively, becomes slower to copy, slower to start up, slightly slower to deploy. And the bigger your microservice, the slower it becomes to scale and deploy, etc. You can see the problem coming. If you choose to not include the data in your microservice, but you choose to create a call and fetch system, you have to go find the data when you need it, find it somewhere. That means your microservice has to do a call out, a connect to some database, chatty. You end up with chattiness, and this is going to be my next presentation is going to be about chattiness in the cloud. But it means extra effort for your service, and it means you become dependable you depend on another system. You become coupled all of a sudden. You're still a microservice, but you need that other component. You need that database to reach out and fetch your data. Advantages: your microservice, your image, your container image, if you like, will be really small. It'll be easy to deploy, etc., etc. And by fetching the data only when you need it, you're fairly sure you have the latest and greatest. So your data is timely and actual and up to date. And that can be a big advantage as well. So this is what you can do with a read-only microservice. Do we have questions anywhere? Should we pause for questions? Looking at my flight controller. No, going on to the next slide. Um, yeah, of course you can have databases. And the difficult one is a stateful service. If your microservice needs data and needs to get the latest data and store any data, you need to keep something. You become a single point of truth, or you become a system of record, as they like to call it. Biggest example is, of course, the order taking. Most people have to do that in school, build an order taking or a stock keeping system. Payment systems are classical example. You cannot afford to lose state on a payment system. You have to be careful with that. You have a limited choice because you would need to call to the storage. You will need to call the point of truth. You'd have to go to the asset database. And your considerations are, can, sorry, can you afford to lose data? Like, can you do all the processing and then do the call out once and come back? And how long can you afford to wait? If your call out doesn't return within a certain time, generally milliseconds or seconds, what should you do? How much capacity can you have? If you deploy your microservice 64 times, you end up with 64 running containers, for example, and all of them have a 50 connection pool. How much effort can that database handle? Is your backup, your back office system going to be able to handle it? And if it doesn't, what is your error handling? What will your service do if the depending component, the database, is not responding? Or if the network falls out, or if something else fails, you run out of memory or that sort of thing. You need to consider all of that. Can I afford to lose data? What should my response time be? How much capacity do I expect? How many users, how many concurrent users can I handle, etc. And to do that, you'll end up with a database, and you'd have to consider the ACID rules and the 13 rules of date and COD. That's the other one. If you've never heard of the 13 rules, make a note. Google 13 rules for databases after this session. This microservice is going to be non-trivial, and you're going to have to depend on a database somewhere. It's always, the database and the DBA are always creating the problems. Let me do a double check. Do I have any questions in the Q&A? No, I keep going. So I outlined the three systems: no data, read-only data, stateful data. And the stateful data, of course, is the trouble that causes the trouble. Now, take a step back. When I was in engineering school, we learned about simple systems being better. We love to geek out on something complex, but a simple system really is better. You can see the presentation was done for an English audience because of the mini. And there is always, in every presentation, the mandatory equivalent of a car or an automotive analogy. But engineering rules of thumb are: please minimize your components. Try to not use too much components. The most simple system is a system with one hammer. You just hit everything. And that's a great system, and it can hardly break. You can break your hammer, but you need a lot of effort. Minimize your components. If you can't minimize your number of components, try to do it with identical components. If you assemble your machine with just one nut, one type of nut and one type of bolt, generally an M17, you have a big advantage over someone who's using 100 different types of bolts and nuts. So keep those engineering rules in mind. They apply to IT. Less components is better, and identical components or less different components is always better. In IT land, can you minimize your microservices? I know it's tempting to deploy 1,000, and it looks really good if you say, oh, my service is deployed 10,000 times in 24 hours. Beautiful. Yeah, but in the end, you might have to keep track of those 10,000 services as well. If you use a database, my instinct would be to use just one database, because then I only have to look after one database. I then create a monolith and I end up being the dinosaur, of course. Maybe I can clone my database. Oracle is really good at that. Other databases are good at that. You can use the same database everywhere. And then you end up cloning it 20 times. If you combine a microservice and a database, you should read up on something called the solid principles. And maybe you can build a solid car in that case. Solid is about single responsibility, open and closed, the Liskov substitution principle, interface segregation, and dependencies. Check it. It comes from the object-oriented programming world, and I think it applies to microservices. Yeah. So what was a microservice about again? About decoupling and all? Oh yeah, decoupling and scalable. And that's why I say, if you can build a standalone one, that's safer. And scalable, one of the things I'd like to stress is the smaller your microservice, the faster it can start, the better. So can you try to fit your data inside a container? If you try to fit data in a container, you can do that using CSV files, CSV objects, associative arrays, anything code. You can include a SQLite database or a DuckDB. You can pick Postgres, which is the container for running a Postgres database. The image for running a Postgres database is about 10% of an Oracle database. Think about that. You can use Oracle XE if you want to go free. You can Oracle free if you want. With Oracle, you end up with a rather fat container, but Oracle has this beautiful thing called PL SQL, which is really powerful. I'm just nudging you towards SmartDB and PL SQL. And you should probably Google the hashtags SmartDB and bring your code to data. You can do a lot inside your database. If your requirements are relatively simple, you can use SQLite and DuckDB. If your requirements are relatively complex, you might consider Oracle and using PL SQL. But it's purely, I'll let you choose. If you prefer not to use any of the stored procedures, that's fine with me as well. So those two keywords. If you need a database behind your microservice, you should consider the thing called REST. If you use SmartDB, you should use SQL as much as you can, because SQL will will massage your data, will format your data, will group and combine your data. You can use views in your database. And if you're a bit of a geek, you should use PL SQL or PLPG SQL. You can do your work inside your data component, and that makes your whole service generally more efficient. And if you use Oracle, you should consider ConvergeDB. Oracle will do things like JSON, document processing, geo-processing. People tend to forget about Oracle Spatial. Oracle will now process graphs and, by the way, vectors. I should put vectors in here. Vectors are so trendy. And your Oracle database speaks REST. The representation for state transitions. Keep that in mind. You can connect to your Oracle database doing a REST call and getting a REST reply back. That makes it a very powerful tool. Oh, and beware, don't create the monolith, mandatory dino warning. In the Oracle world, you come across this set of icons. Oracle will do anything for you. JSON, geographic, vector, any kind of process. They tend to forget that it is in the basis a very good relational database processing tables. Now, if you do that, your dinosaur database, like in the movie, your dinosaur appears to be really, really clever. There's a movie, Jurassic Park, in which a guy gets surprised how clever his dinosaur opponent is, and his reply is, "Clever girl." Will come across that. Your database is a very clever system. So if you use read-only data, remember the microservice that does the zip lookup codes? It only contains data that needs to be read and presented. I'll argue you should put that in a database. You put the smart database inside your microservice and off you go. You can use SQLite. That fits everywhere. This is where I like to look at the audience. SQLite, anyone? And then people go, never heard of. You could use DuckDB, which is the next evolution of SQLite, if you like. But they'll say they're different, but they are very SQLite compatible. You can consider Postgres, which is a relatively small container, easy to deploy. You can consider Oracle. You need a bigger container, but you get all of PL SQL, and I love that. I would choose probably the PL SQL solution because I know that and I'm comfortable with it. You can use Postgres if you want Postgres. If you want to use the Postgres SQL database, you can use Postgres. If you use Oracle, you will use Apex or the Oracle REST interface. No problem. Works like a charm. What you should keep in mind is reduce your calls to and from other components. Reduce your chattiness and reduce your context switches in Oracle speak. You can Google for SmartDB and ConvergeDB if you like. I would choose this kind of setup for read-only data, a small microservice with a database inside or adjacent to it. And I think this is where poll time comes in. You know, some people will say, what's a SQLite? Other people will say, I like it. There are always people in the audience, oh, I totally avoid it. And one smart guy says, no, I'm already on DuckDB. And by the way, I think a lot of you are on Oracle. Is there a poll popping up at the moment?
Yes, Pete, it's trying to get.
I get the thank you. I got the results. I like SQLite. I avoid SQLite. Nobody's on DuckDB yet, and I'm sticking with Oracle. I like you guys. I would probably stick with Oracle if my database is complicated. I would probably use just SQLite if it was a very simple database with 5 tables. If you do use SQLite, I encourage you to explore and discover, but be careful. Strong typing is a bit of a problem. Large volumes are okay, but caveat applies. So I'm not really plugging SQLite, but if you really quickly need an SQL database, SQLite is generally always there. If you're a Mac user, it's just there. You'll find your browsers are using SQLite, for example. But thanks for the poll. I'm going to click that poll away and next slide. So some people go, huh? Others go, yep. Others go, nope, I never use SQLite because my dates get all confused. And then the high-tech guys, no, I'm on DuckDB. You know, DuckDB, much better, which is probably true. My next slide. There you go. Yeah. So recap, state in a microservice. No state, easy. Read only, include your database or do a very careful call out. You choose whatever you're comfortable with. If you need a stateful application, you need to store the state of your bank account, use an asset database, call out to the database. This is the biggie. There's your database and there's your dyno, of course. Yep. If your data is asset, if you do stock keeping and you need to have the correct stock number in your database, use an asset database. I would say put a database behind your microservice. So do the call out to a database. And be careful to reduce those calls. Do a REST call with a single call and a single return, or do a call to a PL SQL routine so you minimize your round trips if possible. I didn't realize how big a problem chattiness, well, I didn't realize how big a problem chattiness would become in the cloud world all of a sudden. There is a presentation on that somewhere in the next month. If you do a database in or behind your microservice, same thing applies. You need to prevent overload. You need to prevent having a DDoS or having 1,000 users at a time. You know, the 1,001 users should get a polite screen saying, sorry, we are busy. You know, we'll try to treat your call later. But be careful not to melt down your database. Again, try to use SmartDB or ConvergeDB, and I'll I think I've said it 100 times now, but stored procedures are probably the most efficient way to process data. So consider using stored procedures. But again, if you're not comfortable with that, build your own, make your own choice, and do whatever you're happy with. Just remember the database can be really clever out there. There's DB. There's some loose ends on the database side because on a stateless database, even if you just query the data, you can still put a lot of logic in your data and process close to your data. There is a big advantage of processing your data inside your database rather than in your service or in your application. The processing in the database means you do not transport the data. We'll come to that. And if you really need more databases, there is a system called CQRS. And please don't exercise me if it, I think it comes out of the Microsoft world, but CQRS basically means you have read-only copies that are kept up to date by a master. So command query response control something. It is worth looking into if you need to distribute data to a large audience. Asset data stores, if you have a critical database, try to limit the number of connections. If a database has 1,000 connections active, $V session, if that counts to 1,000, I'm going to go, are you guys sure you need 1,000 connections? And again, the important thing for a database is generally to protect against overload. Microservices tend to deploy automatically. If you blink an eye, there are 32 of them deployed. That means 32 connection pools adding to your database, and it'll melt down. Please prevent that from happening. You should consider looking into something like the new SQLs, the distributed SQLs. Yugabyte is a product coming out of California and India. Cockroach comes out of England. They are competitors. I have a slight preference for Yugabyte because it's slightly more compatible, but have a look. And if you deploy databases, just come back to what Vlad said at the beginning. I don't want more DBAs, fine. But if you deploy multiple databases or clones of databases, you still need to monitor them. You need to measure whether they hold up correctly. You need to look at trends. Is my usage increasing? What kind of usage? What are my bad queries? What are my bad components? You need to permanently evaluate your database. I know you guys hate DBAs, but it is an unavoidable problem. Please watch out for your database. If this is DevOps, your database is a pet. It is not a swarm. It is not cattle. You cannot create and kill databases at random. Well, you can, but not generally not a good idea. Your database is a pet. You need to look after it in DevOps terms. My main message is always, well, I ask for your clock and tell you the time. But when state is important, you need to consider processing in or close to your database. You need to minimize the number of calls to and from your data component. So look after chattiness. I should have put the chattiness on top of my presentation because in the last year or so, chattiness evolved like a problem, just popping up. It was always there. Oracle Forms in the 90s was chatty, but it was less of a problem because everything was in the same building. Nowadays, calls, number of calls, latency of calls is getting to be a real problem, but we'll come to that in a few months. Your maintenance, think about your maintenance. Remember, less components, less different components. The simple car, I should have put an Indian ambassador out there. I can probably repair an ambassador. I'm probably not quite able to repair one of those Suzukis, but I can still repair a simple ambassador. So, yeah. Using stored procedures, you can call stored procedures using REST. A stored procedure can do a lot of work for you, avoid you from coding inside your microservice, makes your microservice more light. The lightest possible microservice is a call to a REST interface. you should mitigate the problems of monoliths. So I say use stored procedures and call them. Well, if you create too many stored procedures, you're creating your monolith, and you should consider getting read copies or reducing the dependency on your monolith. I think my main message to my development teams at the moment is build some sort of throttle. Make sure you can sustain a DDoS. DDoS is very trendy because everyone's afraid of DDoS. I've seen maybe 2 or 3 DDoSs in my life. But the other lesson is an application or a database gets overloaded easily. You need an elegant system to throttle and prevent overload. Hammer that message home. And then your database is a clever girl. Uh, that's it. Now, here's an analogy. This guy is a sculptor and he carries around these huge rocks. He can do that because he's super strong. It's a comic character, he has the unlimited power. But for the rest of us, we can only carry, I cannot carry that rock. I can carry my tools. And that's the concept of SmartDB. I carry my tools, my code towards the data. I do not carry my gigabytes of data towards my tools. And that's what SmartDB is about. Or nowadays we call it ConvergeDB. I think we should call it bring code to data. But that's a complicated hashtag. In the nice picture, remember those 3 situations? You can have a standalone microservice, no connection to the database, you're fine. Build it, deploy it, clone it 1,000 times, not going to hurt. If you build a microservice that uses read-only data, you generally have a subset of your data. You can still deploy a database with your microservice, or you can connect to the database at will, your choice. And there you go, you can connect to the database. Or if you need asset processing, if you do stock keeping or process other more important data, you will need to call out to your central data. You need to call to the single point of truth. Your microservice is going to have to connect out and wait for the call to come back. And in that case, you can also choose to put the microservice inside the database, PL SQL, or soon to come Graal VM. Well, recommended. We have those interesting times ahead. It's all going to happen. I'm really curious to see how this will develop. Will people start deploying thousands of containers with data in them, or will they deploy hundreds and thousands of containers and call to the database? In that case, at some point, the database will get overloaded and melt down, and you need to think about preventing that now. You're the DBA. There are those new SQL DBAs, the Yugabytes, the distributed databases. Oracle has a distributed database offering, but I'm still a bit skeptical. I could talk about the ACE program. I don't get paid by Oracle. I could be critical. An Oracle distributed database is interesting, but not in my production system. The new distributed databases pretend to be and try to be geo-distributed. So your data suddenly is all over the subcontinent, and that's an interesting concept, and it's super resilient. You can afford to lose servers, and you barely notice it. Is that going to work in the long run? Chattiness and latency are the enemy of that sort of system, but it can be extremely resilient. You lose an area, you lose an availability zone, your database just turns on. It just keeps going. There are many of those new systems, and I'm really curious. Can they handle a system without data? Easily. Can they handle read-only data? Yes. Can they handle asset data in a single point? Yes, maybe. We need to discuss what microservices are going to be like. I should look at the Q&A by now, but remember what happened to the dinosaurs. People say they went extinct. No, the dinosaurs are still here. The birds are the successors of the dinosaur. And maybe that's me. Maybe that's why I fly around on a motorcycle. Don't take my word for all that. Just read your own manual. and study for yourself. In case of doubt, simplify. Use less components. Um, oh yeah, mandatory plugging of my blog, mandatory plugging of my social media, Blue Sky, Twitter. Uh, my biggest quote is always from a German poet. It says, simplicity shows the real master. If you can build your system simple, and if you can explain it in simple words to the next successor, then you have a winner. You know, simplicity shows the master. And in German, that is Beschränkung zeigt der Meister. But that's the Germans. Time for questioning. You can question, I can try to react, and basically you can shoot me now. I'm going to stop sharing and look at the Q&A. Is that the idea? Check.
Yeah,
Yeah.
Pete, you can.
Thank you. Where's the, let me see if I can find the Q&A window. Yeah, back to meeting. Is that, okay. You guys still see my screen, right?
Yeah, you can stop and
Stop sharing. Yeah, there we go. Ah, there's the Q&A for me. Let me scroll. How do you ensure data? Shall I just pick the questions from start? How do you ensure data consistency across microservices? Yeah. The, the quick answer to that is you use one database, and the database has the asset property, and the database ensures your consistency. If you copy data out to a microservice, if you bring read-only copies into a microservice or hard code it into an array in your program, you don't have control over that data and you risk not having consistency. This is why I divided them into three systems. Systems with no data, no problem. Systems with read-only data, you either take a copy and then you risk timeliness, or you call out to the latest data and get it back. And then you have chattiness, you have coupling, you have dependency, but at least you have the latest data. Does that answer the question? The question just disappeared. Thanks. I guess it was answered. If I have two microservices, A and B, do I need to access the same data? Would it be better to call service A to call service B to call the database to avoid duplicate? Ah, you would go calling from service to service. Yes and no. I will advocate for a hub and spoke system. I will tell you to call the database and not the other service. But I know that in telco land, for example, there are a few applications where the data is central in a database, and every application component has a subset of the data, and they need to chat, they need to call each other and say, I've modified item one. I am now in control of item one. And that has to go around the whole ecosystem of running components to know that, service A is now in charge of component one. That creates a lot of chatter. Okay, you can have a requirement where you think you need that, but the latency, or actually the number of calls on a growing system, will stop you at some point in time. And then you need to go back and create a single point of truth and say, at this point, my database is where my value is kept. Anyone in charge of the value needs to lock it and update it. And anyone that needs the latest value needs to query it from the database. There is no way around that, by the way. A single point of truth means a bottleneck. Does that help? The question disappeared. Thank you guys for that. But if serious, if it's not answered correctly, ping us an email or something. The next one is, will AI agents replace microservices? Yes and no. Agents are microservices, probably. Do they serve different purposes? Yeah, I would say that the AI agents and the LLM systems are more like a fuzzy system. They contain uncertainty. They can contain opinions, if you like, or consensus. Whereas a database and a true microservice probably processes something with a definite state at the start and a definite state at the end. An LLM, if I visualize that correctly, an LLM doesn't really hold state. An LLM processes your text, goes out and finds related words and tries to formulate a response. A microservice gets an order to pick up a number, like a converter 32 Fahrenheit into Celsius, and it'll have to come back with zero because 32 Fahrenheit is a zero Celsius. And there is no ambivalence in that. Does that help? Okay, cool, thanks. Which database by mobile apps? Haha, SQLite. But please don't quote me on that. Okay, SQLite, DuckDB, they all work. Yeah. But for mobile apps that need to go on a smaller device and an independent device, I would probably use SQLite. Can we use the same database with different schemes for different? The quick answer is yes, you can, and I think you should. I would very much recommend to use a database with multiple schemas. But again, it will depend on your use case. How can we assure consistency in microservice application that uses different database? I or Laval. I don't really have an answer to that because if you use different databases, something simple as a foreign data wrapper and a database link can become really complicated. So the answer to that is you can probably not ensure consistency across different databases. Um, and then don't click this one away yet. We need to elaborate on this a little. In the concept, in your design, you need to find out what your microservice is going to manage and own in terms of data. A certain microservice will own, for example, the stock of a product. And that means in consistency terms, that means that microservice is in charge of the stock. I have 15 items in stock, and other services will need to call and query that stock from the service in charge. That's the only, that kind of design needs to prevent that you get inconsistencies between services. This is not easy, and this problem is even older than IT and older than databases. But ensuring consistency across what you call different databases or different stock keeping systems or different points of truth is one of the core problems of IT, really. And that's why I can't answer that completely at this point. I probably never can, by the way. Does that help? I'm sorry about that. The next question is for disaster recovery. Are we on to disaster recovery? The microservice will be used for fault tolerance in different regions. Yes. Yes. The quick answer to that is yes. But if you think about it, it is not that much different from a data guard solution where you replicate your data to another availability zone, or a distributed database where you keep 3 copies of everything and you always need a quorum, a majority, 2 out of 3 votes determine this is the truth. And the one vote that has a different opinion, he's out of luck. Disaster recovery using microservice, you will have to look at how it evolves in not just Oracle, but Postgres, Yugabyte, and other databases. How they use things like Docker, Kubernetes to deploy in multiple regions and to always make sure that there is a point of truth somewhere and that there is an availability. We can query the data if you like. This is it's actually becoming a good and interesting engineering problem. Can I? Thank you. It was a good but difficult question, by the way. You think Oracle database should be containerized? Yes and no. If and I'll give you a bit of a duh answer because your production database if it's time critical and big and needs a really fast response time, you need to be as close to the iron as possible. So you need to get to an Exadata and deploy with the least possible layers in between your database software and your stored data on a disk or on a whatever a disk is these days. But if you need to develop and deploy, by all means, use containers to get your developers copies. Use Docker or Podman or Kubernetes to have your test environments to do your regression testing, integration testing, all of that. I think you should use containers, and don't click this one away yet. I'll also give you another one. In way back, we thought a database would never go on a virtual machine because a virtual machine was something ephemeral, something virtual, and it would break and it would get corrupted. Now we only deploy on virtual machines. Now we think containers are a bit ephemeral and maybe not as reliable because there are more abstraction layers. But in another 5 years, we'll be deploying on containers and we won't even think about it, is my suspicion. So you'll go to containers, you will go to something serverless probably without even knowing it, maybe in the end. Does that help? So containers will happen. Yeah. How do you handle data consistency across microservices? Let me give you a quick answer. How do you handle data consistency across micro? You handle it carefully. You think about it. That that would be my very short answer to that. And are there any advantages using Oracle Office? Oh yes. The any advantages of using Oracle? Yes, because but you need to study this. You need to dive into Oracle a little and consider using PL SQL for anything that processes data. Process as much as you can inside the database because that's where your data is, and that's where you don't have to take out the data, you don't have to transport it, and you just reply in the smallest possible message to your calling service. Use Oracle, use PL SQL, and Google SmartDB and try to apply those principles. Does that help? We have 3 minutes left for questions.
Yeah,
Um,
thanks.
Thank you for clicking through the questions. I hope I wasn't rambling. Let me just say one personal thing. I hate speaking to a screen.
Yeah,
You just convinced me. I need to get my motorcycle over the Pamir and get to India.
yes,
There.
that's what we are asking, Pete. So, yes, absolutely. I think, again, this is the way only we can connect the global speakers to the Indian community. But thank you so much for today, spending your
No,
time, valuable time here. Hopefully,
I
we'll see
always
you
enjoy doing.
virtually or physically.
Yeah.
Um, But thank you guys for asking right questions and also others joining this call. So what's coming next? So again, the entire month is we actually scheduled a lot of sessions are coming from Oracle Aces. Please join us again. Somebody said, why I need to register, I need to fill the form. So that's why we make it very simple, straightforward. You can just save it to your calendars and just join before 5 minutes before the webinars, right? Also, please share with your connections. And also, the mega event is coming, Oracle Community Yatra in July. Please, again, mark your calendars, save the dates. Currently, we are working on call for papers and also getting the key speakers. I'm sure you know who's coming. So with that, thank you so much for joining today, and we will see you on Friday. So thank you so much, Pete. Once again, have a nice day.
Recording stopped.